Welcome back to the Frequency Architecture Series, Part 2, talking about applications on frequency and how do applications interact and what is their representation inside of frequency. So first, let's go back a second to look at users and identity on frequency again. So this is what we covered last time, where we have this kind of concept of uniqueness and how is uniqueness represented for users and what do we need there. We have information that's user indexed. This is the social graph, public keys, token addresses, and so forth. Things like profile, things that are indexed to the user themselves. Then we have those things that are time indexed, like social posts and such. All of those kind of either going back to or coming out of that 64-bit identifier that identifies a user. But all of this still kind of is just the structure of the data and how users are represented. Let's talk about applications. Before we look at like applications on frequency, let's look at what applications looked like in the Web 2.0 model. So in this model, we have users. They use an application. So here we have Alligator and Bee using the Strawberry application, and that data is stored in a database. And those users interact with that application, and they're completely forbidden, effectively, inside of that application from talking or interacting with our Camel user on the Grapes application, because they use a different database. There's no interaction between those applications. Now we have also a kind of a Web3 blockchain model, the kind of broader blockchain model, very simplified, of course, but the users are interacting back and forth with the application. The application is getting and receiving kind of information from the blockchain, but the users are interacting directly. So all the write access, all the writes to the blockchain tend to happen from the users directly. So B writes to the blockchain, it's read from the blockchain by Grape application, which then shows it again to the user. And this has some benefits, but for social applications that are very heavy, have a lot of off processing, indexing, how the algorithm that's going to show to the user, this model tends to be both very expensive as well as limited in what data can be stored. And finally, also the fact that the users have to be interacting directly with the blockchain themselves means that the users are having to kind of directly bear the costs of interacting with the blockchain. So to start with a kind of the frequency model of applications, and we'll zoom out as we go here, a user has this kind of initial impact where they're interacting with an application UI, and that application has its own local data storage. So this looks very much like that Web 2.0 model. So we keep kind of expanding out and we see that, hey, the local app storage is kind of also interacting on behalf of the user on the blockchain. There on the blockchain, we still see that kind of user identity storage, the graph storage, that content discovery storage, the delegation storage that we'll get deeper into here in a minute. And this is all kind of well and good, so we can zoom out one level deeper and see that, hey, there can be more applications, all of them kind of interacting. The applications are interacting with the blockchain, and the user, we see here, user B can use more than one application, but also user A and user C, because there's this shared blockchain between them of frequency, we get this ability for user A and user C to kind of interact with each other, even though they're using entirely separate applications. So we get the advantage of that Web 3 model, except we don't have, as you see here, with one exception we'll get to in a bit with user B, user A and user C are never interacting directly with the blockchain. They're able to do something called delegation. And that delegation storage on the blockchain is what enables user A to say, hey, I am using an application. I want that application to be able to do things on my behalf. And so here we can actually take a closer look at the delegation storage in an abstract way, at least. We can see that user A is delegated to the Strawberry application X, as is user B, and user B is only delegating content in this example, but user A is delegating both graph and content. So application X might not be able to change user B's graph, but it can post on behalf. And we see something a little bit different here with application Y. And so this gives us a structure whereby users can interact with applications and applications can interact with permission of the user on the blockchain, with specific permissions of the user. And so we come back all the way out to the last piece of the puzzle here, which is those users, after they delegate, how do they get out of that delegation relationship? They don't want to have to trust the application that made the delegation. So there is a direct, no fee delegation revocation. When that then that delegation is created, effectively, that pays for the future revocation of that delegation by the user directly with no fees necessary. And so the user still has that ultimate control, even if the application says, I'm not going to allow you to do something, or they decide they don't like the application. They don't have to trust the application. They can go directly to the source and say, no more on that. And so here we have kind of that entire structure again, where users are able to use the blockchain and gain value from the blockchain, and the interoperability between applications and the ability to use different applications that show things in different ways. Yet users still have that ultimate authority of who is allowed to do things on their behalf by, as a last resort, being able to go to the direct cost. Now, this still gives us a great structure for applications, but it still asks the question of how are applications, if they're paying the blockchain or doing actions on the blockchain, there's still those costs that are being accrued. Now, some of this is a model same to how it exists in Web 2, right? The application doesn't charge users for their AWS bill, for their hosting services bill directly. They offset those costs through other things. But we still have a lot of questions on like, how does this economic system work? And we have something very special in frequency that we'll get to next time, talking about these economics on frequency, very special system called capacity that allows this system to work and for applications to really collaborate with each other and allow for the interoperability between applications. So I look forward to seeing you in part 3.